Hey guys, welcome to Exam 2 written portion tutorial, and it's by Katie Jones, so let's get started. So question 1. Suppose that an autosomal dominant polycystic kidney disease, or ADPKD, affects 1 in 750 individuals in the human population. For parts A through C of this question, please write your answer to 4 decimal places. What is the frequency of the non-disease allele in the human population? So, I took 1 minus 750 and used 749 divided by 750, and I got 0.9978. 1b. What is the frequency of the ADPKD allele in the human population? So this one I just used 1 divided by 750, and I got 0.0013. 1c. What is the frequency of the heterozygous individuals in the population? And so what we do is 2 times P and Q. And so 2 times 0.9987 times 0.0013, and we got 0.0026. So 1D, out of the population of 1 million people, how many heterozygotes are expected? So we're going to take 1 million and multiply it by the answer we got in C, the 0.0026, and we got 2,600 heterozygotes. 2. So we need to consider the following DNA molecule. We'll go see here. So A, the letter W above indicates the phosphorus group. The letter X above indicates the deoxyribose. The letter Y above indicates thymine, and the letter Z above indicates guanine. 2B, indicate 5' end and the 3' end of each DNA strand on the image above. So we have to remember that DNA is anti-parallel. So 5' on top of the first strand and 3' is on the bottom of the first strand. And then 3' on top of the second strand and 5' on the bottom of the second strand. 2C. On the image above, indicate the portion of the molecule that is considered to be the backbone, and it's the phosphorus group plus the sugar. Phosphorus group plus the sugar are considered to be the backbone of DNA. 2D. On the image above, indicate the portion of the molecule that gives DNA a net negative electrical charge, and this is the phosphorus group. So 3. So we have these alleles in alleles in fruit fly, and we're looking at 3 of them, the recessive and dominant alleles. And so suppose that a female fruit fly that are heterozygous for 3 genes are crossed to males that are homozygous recessive for the 3 genes. The progeny produced by the cross are as follows. And so, 1, we got the observed data. And so 3A, determine the allele arrangement in the heterozygous parents. So we can see that that's the parental cross on top, and then we take the 2 biggest phenotypic, the parental recombinants, and then we get what it's supposed to look like. 3B, determine the gene order of these 3 linked genes. And so we take the recombinant DNA, which are the 2 smallest phenotypic observed numbers, and we kind of do a V thing where we move the middle of the alleles around. And so on the right hand side with the check is the right one. So 3C, construct a linkage map showing the map distance between 3 genes. And so we kind of make, like on the ends, we're going to circle 1 on the end and 2 on the other end. And then we're going to get the recombinant DNA, whose numbers are in the middle, between the largest and the smallest. And we're going to divide those by the number of individuals, multiply it by 100, and we get the map units. And then we can make our linkage map. And then 3D is going to calculate interference. So we're going to take the map units, divide them by 100, multiply them together. And then we're going to multiply that number by the number of individuals, and we're going to add the recombinant DNA, And then C is going to be taking that recombinant DNA and divide it by our number from 0.0035 multiplied by the number of all the individuals. And then 1 minus C equals 0. And so the inference is 0% or 0. 4. The Chidiac-Higashi syndrome is a rare genetic disease inherited as an autosomal recessive fashion. The non-disease allele is D, while the Chidiac-Higashi syndrome allele is small d. Suppose that the Chidiac-Higashi syndrome affects 1 in 32,000 individuals in a certain population. In all cases, parts A and D, well, through D, please indicate your answer to 4 decimal places. So 4A, what is the frequency of the small d allele in the population? And so that's the diseased allele, so it's 1 out of 32,000, which is 3.125 multiplied by 10 to the negative fifth. 4B, what is the frequency of the dominant allele in this population? And so we're going to do 1 minus 32,000 and get 31,999 divided by 32,000 equals 0.9999. C, 4C, what is the frequency of the homozygous dominant genotype in this population? And so we're going to take 0.9999 and multiply it by itself, and we get 0.9998. And 4D, what is the frequency of the heterozygous genotype in this population? So again, we're going to take 2 times the 0.9999 times 3.125 times 10 to the negative fifth, and we get 6.2494 times 10 to the negative fifth. And thank you for watching.